Hey there, science fans. Today we're talking about something you use every day but probably don't think much about: electric cables. You know, those insulated wires that bring power to your lights, gadgets and everything else. They're not all created equal. Just like you wouldn't use a garden hose to fight a fire, you can't use just any cable for any electrical job. That's where electric cable ratings come in. These ratings are like safety guidelines printed right on the cable. They tell you how much electricity the cable can safely handle. Ignoring these ratings is like ignoring a speed limit sign. It could lead to serious trouble like overheating, fires, or even electrocution. We don't want that, right? So understanding cable ratings is crucial for anyone working with electricity, from electricians to DIY enthusiasts. Stay tuned as we delve deeper into the world of cables and learn how to stay safe while keeping the power flowing.
Now let's talk about one of the most critical cable ratings, current rating. You can think of current like a river and the cable like its channel. The current rating tells you how much water, electricity the cable channel can handle before overflowing, overheating. This rating is measured in amperes, or amps for short. The higher the amperage, the more electrical current a cable can safely carry. Too much current for a cable is like trying to force a whole river through a narrow pipe. Things will get backed up and potentially explode. That's why choosing the right current rating for your electrical needs is crucial. Using a cable with a current rating lower than your appliance's needs is a recipe for disaster. Remember, it's always better to be safe than sorry when it comes to electricity. Here's something interesting. The size of a cable directly relates to how much current it can handle. Think of it like a highway. A wider highway with more lanes, larger cable area, can handle more cars, electrons, flowing smoothly. The cross-sectional area of a cable, measured in square millimeters, plays a vital role in its current carrying capacity. A thicker cable with a larger cross-sectional area provides less resistance to the flow of electrons, allowing more current to pass through safely. A simple way to visualize this is to imagine electrons as tiny cars driving down the cable. The wider cable provides more lanes for these electron cars to travel side by side, reducing congestion and preventing overheating. In short, the bigger the cable, the higher its current carrying capacity. This relationship is essential when selecting cables for different applications, ensuring electrical safety and efficient power distribution. Now, let's talk about a scary situation: thermal runaway. Remember how we said that too much current can cause a cable to overheat? Well, thermal runaway takes that to the next level. When a cable overheats, its resistance actually increases. This increased resistance causes even more heat to be generated, leading to a dangerous cycle that can ultimately result in a fire. Imagine a snowball rolling down a hill, getting bigger and faster as it goes. That's what thermal runaway is like: a vicious cycle of heat and resistance, ultimately leading to a meltdown, literally. Preventing thermal runaway is all about choosing the correct cable for the job. Factors like cable size, material, and ambient temperature all play a role. By understanding these factors and selecting cables with appropriate ratings, we can ensure electrical safety and prevent potentially disastrous consequences.